What's going on, my ASVAB party people? Anderson here, your ASVAB coach. I hope you're having a good day. Let's go ahead and take a look at what we're doing today. Everybody's favorite distance, rate, time, word problems, right? So we're checking this out, and we're gonna be going over a 2-hour class here where we're gonna go over plenty of notes, examples, and answering a lot of questions. That way you can feel more confident moving forward. And so, if you like the way that this class goes for you, make sure to like and subscribe in this video, but more importantly, if you believe that this kind of help works for you, go ahead and reach out to me. This is my number right here, 567-698-8867. Go ahead, shoot me a text. Let me know that you're interested in my full program. That way, I can set you up for success. The full program comes with all the classes, all the recordings, study guides, plans, flashcards, worksheets, my support. You'll be able to text me anytime you need help. Seriously, it's everything you need to pass this test without all the stress. And so, there's my number right there again, 567-698-8867. Shoot me a text if you're interested. That way, we can help you succeed. But go ahead and enjoy this video. Seriously, there's a lot of good stuff in here because we're going to show you how to look at these keywords, how to identify what distance is, what rate is, what time is. That way you, again, can raise your score and get the job you deserve. So without further ado, let's go ahead and get started, and let's ace the ASVAB. Cheers. Here we go. Let's go ahead and let's get started, guys. So before we begin, before we get into all the word problems, before we get into all, the slight torture that we're going to go through with these word problems, we got to go ahead and know our basics, right? We got to know what to call things. We got to know how to look at this. And so obviously, if you're on your phone right now, this is going to look a little small. Don't worry, I got you. Let me go ahead and zoom on in here because we're going to be talking about the distance, rate, time formula. No worries, Carrie Ann, I got you. So with the distance, rate, time formula, remember, it is all about understanding what distance, what rate, and what time look like in a word problem. Because you can memorize the formula, but if you don't know what to do with it, not going to help, right? So let's go ahead and start off with distance. So remember that distance is always going to be the amount that you're trying to accomplish. So for example, everybody is 100 miles. Like if we're driving and we're trying to go 100 miles, yes or no, is that a distance? If we're on the road trying to drive 100 miles, is that a distance? And I'm seeing a lot of yeses so far. Okay, I agree. I absolutely agree. Okay, what about, let's go ahead and say we're going ahead and we're on an airplane. And an airplane, that airplane's traveling like 12,000 kilometers. So to get to that 12,000 kilometer mark, is that 12,000 kilometer mark a distance? Yes or no? All right, still yeses, and I agree. Still yeses, and I agree. Let's go ahead and say we're at a toy factory, and this machine is producing toys, and after a while, it produced 7,000 toys. Is 7,000 toys a distance? I see a lot of no's, and that's the first lesson of the day. Yes, it is a distance. It absolutely is. So the one thing that not everybody knows, and this is really what I want to really flip the script on, the biggest mistake that a lot of people make when it comes to applying this formula here is that distance, you don't really see it as anything other than feet, inches, miles, centimeters, kilometers. That's all you see it as. Distance is really what you're trying to accomplish. For example, listen to me here. If we're talking about a regular distance problem that you and I know both about, you could be thinking, oh yeah, we have Justin who's driving at a rate of 45 miles an hour. He drives that distance for 4 hours, and he eventually totals a distance of 180 miles. You heard a distance, rate, and time in there. You're feeling pretty good. But let me just flip the script. You can do the exact opposite or the exact same thing with a different situation. So let's go ahead and say we visit a toy factory. And once we turn the machine on, this one machine can produce 25 toys an hour. After 4 hours, that machine produced 100 toys because we have 25 toys per hour times 4, that's 100. Everybody, now I'm going to ask again, yes or no, is that a distance, rate, time word problem? It is. And I want to follow up and ask, does it make sense? And don't just say yes, say it makes sense. If it does make sense, what I just said, if it makes sense, type out it makes sense. So that way I can tell the difference between the yeses and the making sense. Because remember, one thing that you kind of need to really wrap your head around is that distance is not just a distance, it's the amount that you're trying to accomplish. For example, here's another distance, rate, time, word problem that I know you know. Anybody ever heard of a word problem where you're trying to fill up a pool with water? And it says that this pool can hold 200 gallons of water, and it's pouring water into the pool at a rate of 12 gallons a minute. Have you heard that problem before? That is a distance, rate, time, word problem. Absolutely. Absolutely. All day. All day. So we really need to wrap our heads around this idea, again, that distance is not just distance. And we'll talk more about that. If there's a problem in here that we can find on that, for sure, tomorrow, we're going to have plenty of them, because one thing that I haven't done much of are those filling up the pool problems. So I will be doing that. Exactly, Mario. That's another example. So Mario gives the example of, hey, if you're trying to make 100 cookies and you're making 20 cookies an hour, how many hours would it take? Absolutely, because you're trying to accomplish 100 cookies. This is the rate at which you're accomplishing it, and you're figuring out the time to accomplish it. So that's exactly it. That's correct, Mario. Correct. So let's go and keep taking these notes down. So remember, again, distance can be miles, yards, feet, kilometers, all that good stuff that we know. But what's lesser known, money and other currencies, weight, items, reading pages. Has anybody ever read a word problem? Oh, this person reads, 72 words per minute. How many words can we expect them to read after 30 minutes or half an hour? That's another distance, rate, time, word problem. That's another one. You can apply these strategies to those problems. So I really want to make sure you know that. So now let's go ahead and talk about rate. Okay. A word a minute sometimes. That's me when I'm just waking up in the morning. So with that, let's talk about rate here. So rate it used to be a tricky one for a lot of people. And I'm glad that we've continued to work through this, because I think I have a way that you can automatically find that rate no matter what. And so here we go. Rate is really going to be the pace, the speed, how quickly you're accomplishing that distance or that goal. And so here's something that I want to kind of just point out. And if you've been in this distance, rate, time class before, where I've done this before, shut up. Appreciate you. And then everybody else, I'm going to go ahead who's here for the first time, who's seeing this for the first time. I want you to answer this. Those of you who know the answer to this, shut up. So let's look at some examples of rate, and let's just try to point the pattern out. Okay, try to point the pattern out. So we have miles per hour, dollars per hour, pages per minute. These are all examples of rates. We have pounds per month, and we have raindrops per second. Can anybody tell me what the commonality is here? Was there a pattern here? Is there a coincidence that we might be noticing? The word per. Exactly, the word per. And not only the word per, but what comes before it and what comes after it. So just really quick, let me just point it out. Just take a look right here. You see that we have miles per hour. Everybody, in this case, what would miles be? Miles would not be the rate. The whole thing, miles per hour, is a rate. But miles by itself, what would we consider that? What would we consider that? Mara says distance, 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 distance. Right on, spot on, perfectly said. Perfectly said. That is a distance. Now, everybody, let's take a look at hour. What kind of a unit is hour? What kind of unit is hour? That's time. Yeah, absolutely, that is time. And so let's think about it. What really makes up a rate? Distance over time. Distance per time. Just another example here. Dollars per hour. You're trying to earn money. Distance. This is the time it takes you. Distance per time, or distance over time. Distance over time. Distance over time. Distance over time. So if this helps anybody at all see how to identify rate units, right there. The word per is a dead giveaway, but you're not always going to see per. You're sometimes going to see for every. So for every also works. That also works for sure. But the goal here, everybody, the goal here is to always be able to recognize the goal, the distance, and also being able to identify the rate or the speed or the pace that you're getting to that goal. So anything that sounds like how quickly you're doing something, boom, that's a rate. And then time is obviously time. You'll see time all over the place. Now, the one thing with time that I will definitely point out, right here, please write this down. It's this. So time is how long it takes to achieve the distance, but pay attention to the units. Pay attention to the units. Right there. Pay a special close attention to those units for sure. Has anybody ever tried a problem out where it's like, oh yeah, you know, this car or this boat or this bike is going at 42 miles an hour. How far will they go in 35 minutes? Anybody ever seen that? Yeah, it's gonna be a little frustrating, right? So really the only way that they'll try to like get you with time is gonna be with different units. The ways that they'll try to get you with distance, they'll try to throw different things in there, like not just distance, but like toys or water or pouring something and things like that. And with rate, typically people have a hard time identifying the word per. That's going to be it right there. The word per or for every or anything that shows a speed, there's rate right there. Now, with that said, I'm not going to expect everybody here to be like, oh yeah, this is incredible. I get this automatically. I know. But what I'm asking is, does this kind of basic kind of overview, I know it doesn't go into the details, but does this basic overview kind of make sense? One, distance isn't just distance. Rate can be pointed out with the word per or speed. And then time, just look out for the units. Does that kind of make sense? Hey, what's going on, Taylor? Welcome in. Hey, no worries, David. You know I got your back, man. And you know, obviously, we're going to need to see some practice, some examples. I got you guys. But this is really the main thing that I wanted you to really start off with. Now, while we continue here, this is also something that I haven't included in the past classes, but definitely something that we need, that I always express that I haven't written down yet. So this is something that I want you to write down here. One of the key things about distance rate time problems, because it's not just about identifying the units, it's about identifying how those units belong in the story. Remember, guys, word problems are all about storytelling. So if we're looking at word problems here, and it comes to distance rate time, you have to be consistent. You've got to be consistent. Because the thing is, if we're going to go ahead and let someone in here, because the thing is, in red, you have to represent the formula the same way, or you have to represent the same things in the same way. Everybody, what does that sound like? Represent the same things in the same way. What does it sound like I'm talking about? What topic? Who knows? Exactly, Kelsey, ratios. Yeah, I've said this all day, every day, right? With ratios and proportions, you got to compare the same things in the same way. Yeah, distance rate time problems. Yeah, those are proportion problems. Those are ratios. You know, they're not done in the same exact way. You can do them in the same exact way, but I'm not going to get into that rabbit hole today. But really, the one thing you want to know today before we begin these word problems is represent the formula in the same way. So read right here in black, both paragraphs. You know, so if you're looking for, let's say, Bethany's time, then you'll need to make sure that the formula includes Bethany's distance and Bethany's rate. You know, you can't have a distance rate time formula trying to find the amount of time it takes, you know, Josh to read a book, and then you're using the rate for his buddy Brandon or the distance for his friend Katie. You know, that's not going to work. If you're talking about the time it takes Justin to do something, then you need the rate for Justin and the distance for Justin. You cannot talk about different things in the same formula. Everybody, yes or no, do you have that right there? So one thing you need to write down. All I'm asking is if you got it written down and you heard my words, you need to make sure that for distance, rate, time, each of those things represents the same thing. And then lastly over here, if the problem is asking you about finding the entire trip, the distance for the entire trip, then guess what? You're going to need to go ahead and find the time for the whole trip and use the rate for the whole trip and vice versa. You have to make sure you're consistent with the representation. As long as you understand that, plus the distance, rate, time, that's it. Like, you're in a good spot to start, and then I'll teach you these little tips and tricks for sure. But it's all about being consistent. All about being consistent. So word problem strategy, we're gonna go through some warm-ups now. Remember everybody, my 3 steps to word problem success. First, what do you want? Second, what do you have? And then third, what's the connection? Everybody, quick question. What do I mean when I say, what do you want? What action do I want you to automatically do at the start of every problem? What do you want? What does that mean? That's right, May. May, you've been paying attention. I love it. Yeah, read the question first. Read the question first. Read the question first. First, okay? Not after reading the problem, not after a couple of sentences. No, read the question first. It's going to tell you exactly what you want. That way you're not stuck sitting here like, okay, yeah, so Chad has 27 gazelles, but why do I care? No, you start with the question and you know exactly what you need to look at right away. No problem. You're good. Number 2, what do you have? Everybody, what does that refer to? What action should you take after reading the question first? Right. What information do you have? What information do you have available to you? So this is valuable information, guys. Write this down. What do you have means basically mark the info. Mark the information. And then lastly, what's the connection? This is where you build your plan. So if there's a formula to be applied, apply that formula. If it's a regular old, start to finish or creating your own solution, this is where it happens. But you can't expect yourself to build a solution if you don't know what the goal is and you don't know what information is present. So you see how the timing of this works out? You don't want to just start by trying to throw things at a formula that you're not sure works. You got to make sure that you know what's supposed to go where. That way you can have a nice, smooth process, as opposed to letting test anxiety take over and then blanking out, and then you hope for the best by taking a guess, right? So there it is. This is where you build your plan. Build your plan. All right. Sweet. It's all good. Yeah, it's all good. I know that blanking out on word problems, number one reason that a lot of people fail the ASVAB, but that's simply because of, just mispreparation. I wouldn't say it's a lack of preparation because I've seen people study for months and still fail. But the thing is, we need to prepare the right way by giving ourselves the best chance, not by just trying to memorize a bunch of problems, but by actually understanding that process, by being confident, knowing that this goes here because of blank, blank, blank. Not, I hope this works, So with that, I'm gonna go ahead and let these 3 people in, my tardy folks here. But let's go ahead and take a look at some warm-ups here. And if you need me to go back to this in a few moments, just let me know. I'll come back before we go to the second problem. So let's start with the guided warm-up number 1. If you're looking at this thinking that it's super, super easy, don't worry, you know me. By the time halftime hits, it's gonna be a much different class. So here we go. Everybody, what's the first thing we need to write down? What's the first thing we're writing down? The question. We're going to read the question. We're going to read the question. So if it says, how far did the car travel? Everybody, if you had to underline 1, maybe 2 words here, what would you underline? Mario says far. That is 1 word I would definitely highlight. You could say travel, but when you say how far and you say travel, I think you're still talking about distance, right? No, in the question itself, just in the question sentence. So how far did the car travel? We got far. What's one other thing that we should definitely highlight? Kev, right on. Car. So right here, right there. So I'm gonna go ahead and underline this to really make a point. And I know this is somewhat of a trivial question, but I really want you guys to pay attention, because if we can really master these fundamental questions, we can apply that strategy to those really complex ones, and it's going to feel a lot easier. Trust me, we're going to get there, but let's master these easier ones first. So everybody, right here, focus up. It says how far, so that shows distance. When you say how far, you're talking distance. I think can we all agree on that really quick? When you hear the phrase how far, we can all say distance, right? All right, cool. Just open, making sure. All right. And so then how far did the car travel? Remember that consistency I was talking about? If you're looking for distance of what? You got to know what you're looking for the distance of. So we're looking for the car's distance. So everybody, we're going to need whose rate? The boat's rate, the car's rate, the plane's rate. Which rate are we going to be looking for? The car's rate. And how about the time it takes? The time it takes. Are we looking for the plane's time? Are we looking for the sun's time around the earth? What are we looking for? No, the car's time. Exactly. The car's time. And I think I almost said that the sun revolved around the earth. That was hilarious. But yeah, there we are. I don't know if anybody caught that, but I just kind of played it back in my head and I was like, okay. So we're looking for the car's distance. So what do we want? We're looking for the car's distance. Right there. So now we're going to ask ourselves, well, what information do we have? What do we got to work with? This is just like a construction worker or a builder or a contractor coming in and saying, okay, tell me what you want. You know, what are we trying to build here? Okay, what do we have to work with? What's the space looking like? What's your budget like? Okay, cool. This is what we can do. So this is real world how anybody in any business runs a business. It's like, okay, what's the problem? Okay, what do we have? What can we do? That's what this is all about. So now we're at the point of what do we have? What do we have available to us? So everybody, if we look over here, a car travels at an average speed of 42 miles per hour. Everybody, what kind of a unit is 42? And second, how do you know? And if someone wants to raise their hand, I'll go ahead and call on you on the mic as well. So I see people saying that it's a rate. Some people saying it's distance. Okay, Mario says it's a rate. And he said per. The word per gave it away. Exactly. The word per gives it away. Miles per hour right there. Miles per hour. So boom, that rate that we have is 42 miles per. So let me highlight that again just to make sure that we understand that. Per hour. Booyah. Okay, cool. And then lastly, we see it says, you know, the car travels at an average speed of 42 miles per hour for 5 hours. So that's a standalone time unit, you know, hours, seconds, minutes, hours, days, weeks, years, decades, millenniums, centuries, you know, that's all going to be time. So right there, 5 hours. Equals 5 hours. All right, one thing I want to do before we move forward, everybody go ahead and type out the formula, not with just the letters, the entire formula for the first time. Then moving forward, we'll do the shortcut version. So give me the whole formula. You should have it written down. Randolph, close, but you got to spell out what D stands for there. There you go. I'm looking for distance equals rate times time. Everybody type that out. Nope, not just D equals RT for the first time. I want everybody to go ahead and do distance equals rate times time. Everybody. And then the next time we'll do DRT. So you're good. But for right now, I want everybody to type it out. Distance. And don't feel bad because I actually have to write it out like 25 times this class. So don't worry. You'll be fine. So distance equals rate times time. Let's commit this to memory. So with that said, we have our time being 5 hours. We have our rate being 42 miles per hour right there. And so that's it. That's really it. So we have distance is going to be equal to 42 multiplied by 5. Before we even do the calculation, is everyone good? Does this make sense? Before I actually calculate, does this make sense? Okay, right on. So far, and I want everybody to answer. Like seriously, you know, you can be candid, you can be honest. I am not the type of person that's just going to overlook anybody. You know, I want to make sure that you're good before we move forward. Okay, cool. Sounds good. So let's go ahead and plug things in. Let's plug them in. Let's have some fun here. 42 times 5, using mental math, multiplying by 5 is the same as multiplying by 10, then dividing by 2, because 10 divided by 2 is 5. So that's going to be 210. So D, distance, equals 210 what? 210 what? Is it miles per hour? Is it miles? Is it hours? What's it going to be? Miles. Yep, just miles, just miles, just miles, just miles. It actually shows it in the answer choices as well, but that's neither here nor there. So with that, it's going to be 210 miles, 210 miles. And so the way that we get 210, Alvin, is by multiplying the 42 and the 5 together. So I'll show you right here. 42 times 5, we'll go ahead and do that. 2 times 5, that's going to give us 10. Then 4 times 5, that's going to give us 20. Carry that 1, that's going to give us 21. Making the answer 210 right there. So hopefully that works there. Hopefully that works. So with that, my party people, let's go ahead and let's browse around. Let's take another look at a different example that we might be running into. So let's go ahead and take a look at something here. A motorcycle travels at a rate of, everybody, what did I do wrong? Hit me with it. Read the question. Read the question. Monique, don't worry. We're using these questions as a way to really warm ourselves up. We're going to get into that vomit-inducing swirl of problems in a second, so you're good. But with that, we got to read the question first. And the question here is going to read, how far did the motorcycle travel? How far did the motorcycle travel? So we're basically looking for what of the motorcycle? We're looking for what? Right, we're looking for the distance of the motorcycle. So distance for the motorcycle. Jesus. There we go. Equals blank. All right, sounds good. And everybody, based on the answer choices, we're looking for blank what? Miles, miles per hour, kilometers. What are we looking for? Right, miles. Sounds good. All right, great. Now, step two. Step two. This is where everybody who went ahead and solved the problem already, this is where I want you to go ahead and just grab some drywall, contact your local Lowe's or Home Depot if you are running low. And this is where things get interesting. So watch this here. It says a motorcycle travels at a rate of 110 miles per hour. Let's write that down for a second. Let's go ahead and write that down. 110 miles per hour. Okay, sounds good. Sounds good. So everybody, is that a rate, distance, time? What is that? And tell me what gives it away. Okay, it's a rate. And the word per gives it away. Exactly. It's a speed, right? Miles per hour. That's how, when you're driving, you're looking at your speedometer. Yeah, miles per hour is exactly what it says. We're feeling pretty good about that. Cool. Per, that gives it away. That's a rate. Now, everybody, what's that time? Okay, the time is not 30 or 30 minutes, right? 30 minutes. Okay, cool. So let's go ahead and mark that down there. I saw someone had a question. Let me actually address that question because I don't think I read it properly. I was trying to read it fast. Oh, so Abraham, your question was, how far is distance? So whenever you're saying how far, that's always distance. Because think about it, like how far? You know, like 10 miles. Distance. Distance. So with that, boom, we have over here in red, we got 30 minutes, and we're going to consider that time. So everybody, I think it's fair to say, right? If I were to go ahead and just go ahead and say, you know, distance equals rate times time, and I go ahead and just replace the rate and the time that I have, I should have 110 multiplied by 30, right? Right? That's exactly what I should have, right? Yeah, maybe, huh? Yeah, it's exactly what I should do, right? It's exactly what I should do. No. Anybody want to pick up the mic and tell me what's wrong with this? What's wrong with this setup? Anybody want to pick up the mic? What's wrong with this setup? Parmita, go ahead and raise your hand. So Mohammed first, since he got to it first, and then Parmita, I'll let you follow up if there's anything else to add. Go ahead, Mohammed. Welcome in, man.
Hello.
There you go.
We got the rate per hour, and we had 30 minutes.
Let's zoom on it right
So
there.
yeah, so either we do per minutes, then divide on 60 at the end, or we just do it at the hour at the beginning and it's the end of the day.
Exactly. But the fact of the matter is you have to notice that difference in units, right? You
Yes.
have to notice it no matter what. How you handle it, up to you, right? You can convert it at the beginning, you can convert it at the end. It's really up to you, but you have to realize it's there. So, so thank you for that response, Mohammed. Parmita, do you have anything to add there? And if you don't, it's all good. But is there anything or how would you handle this?
He stole it. But good job, though.
Thunder? It's all good. Just go ahead and sit back. I got your player. Go ahead and cry. It's all good. So with that, let's go ahead. Let's go ahead and talk about how we're going to solve this. But before we start solving it, did anybody here who got the answer 3,300? Are you seeing why that's incorrect at this point? Are you seeing why that's wrong? Damn, too cocky. It's all good, man. It's all good. So the reason that you can't just straight up multiply 110 and 30 and think that it's all good is because you have to be consistent. Remember, the way that they're going to try to trick you with time units is by giving you different units for time. Different units for time. So think about it like this, everybody. Let's go ahead and say, let me use an easier example. Let's go ahead and say I'm going, and listen up, 40 miles an hour, right? Let's say I'm driving 40 miles an hour. And then I tell you that I'm driving for 30 minutes. Everybody, is that 30 hours? No, it's not. That's actually half of an hour. Everybody, yes or no? Do we all understand that 60 minutes is an hour? Let's just make sure that we understand that real quick. Okay, 30 minutes is half of an hour. So if I'm driving 40 miles an hour, if I drive half of an hour, so half the time that I'm doing, well, that's 40 divided by 2. That's going to be 20 miles that I've driven. 20 in the first 30 minutes, 20 in the second, making that 40 miles per hour. So if I'm looking at this problem now, if I'm driving at 110 miles an hour for 30 minutes, everybody, 30 minutes is half an hour. It's not going to make sense if I end up going 3,300 miles in 30 minutes. Now, if that's possible, please hit me up because I will pay for gas. I would absolutely love to ride with you. But at the end of the day, that's not really making a lot of sense, right? How can you go faster in 30 minutes than you would go in an hour? Makes no sense, right? So 2 things that we can do here, everybody. 2 things. 1, convert the minutes to hours. Or 2, at the end, convert that hour or the minutes into hours. Like, it's really up to you. So really all you have to do is divide by 60. That's it. That's all you have to do. Just divide by 60. So again, just make sure to turn the 30 minutes into hours. And that will give you half of an hour. That gives you half an hour. That's what that gives you. Exactly. That's a jet plane, Adonis. Exactly. Exactly. So I'm glad we get a little bit of the humor in there. So with that, boom, you can just go ahead again, divide the minutes by 60 to get to hours. Write that down if you need to. To convert minutes to hours, divide by 60. Okay. To convert minutes to hours, divide by 60. And so once we do that, we'll replace the 30 over here with half. And the great thing here is that all we have to do is do 110 divided by 2. That's what the answer would be. And so with that, we'll just go ahead, divide 2 into 110. 2 goes into 11 5 times. Subtract 10, get the 1, bring the 0 down. 2 goes into 10 5 times, and we're done. And we're done. And so, besides the actual math part of things, I want to know if everybody understood that, 110 miles an hour times 30 minutes. I just want to know that you understand that that right there didn't work. Yes or no, does that make sense? And to answer your question, you can absolutely absolutely huge proportions to solve this. It's just, I mean, you might as well just use the formula, the distance rate time. Like you can, it's just like, you might as well just use this formula for sure. So Krishan, I got the 60. I got the 60 because there are 60 minutes in an hour. So right here, what we're doing is we are converting this part right here. We are converting 30 minutes into hours. That's what you're doing. You're converting minutes into hours. So that's where the division of 60 happens. You divide minutes by 60 to get hours. And number two, we got the two. The two came into play once we got the half. Basically, when you're multiplying fractions on a regular number, this multiplies with the top. So 110 times 1, that's just 110. And the 2 stays right there on bottom. So that's where that came from there. And so, Jose, I'll definitely take your question there, boss. What's going on, man?
Oh, good, coach. No, I got it now. That's what my question was. I was like, but then I saw there's where I got, but you explained it right now. Thank you, though.
Hey, no worries, man. I got you. No worries. Cool. And so with that, hopefully that does make a little more sense there. Don't worry, we won't be seeing much of these in today's class. I will be adding more of those into Math Bootcamp. But today I want to focus more so on the setups of these problems to make sure that you're good to go. So with that, here's another type of distance rate time problem. Well, let me just answer this. Brooklyn Mahone. So if it was 1/3, would I do the same? Yeah, absolutely. So if we're multiplying by 1/3, the 3 goes in the denominator, the 1 multiplies with whatever is there. Yeah. So with that, here's another type of problem. So this one here is a pretty common one, but this is where I'm not going to give away too much about this one, but this is where reading the question first is way too important, way too important. So watch this. Question is, what is the total distance that Brian drove? So what was the total distance that Brian drove? Okay, everybody, what are we looking for? What are we looking for? Okay, we're looking for distance. That is correct. May, yep. Christian, yep. We are looking for distance. That is right. And so if you didn't write the last question, don't worry. I'm going to go back at the end of this one. Don't worry. I got you. I got you. So we're looking for the total distance. So here, we're looking for the total distance. Blam. So total distance is very important to note here, because everybody, how do you typically get a total? Typically, right, by adding everything up. And so my idea here is going to be the following. To get the total distance that Brian drove, because again, we're talking about Brian here, what we're going to do here is we are going to find the distances because we need to add them all up. Now, my question is, are all of the distances handed out to us? Like, is it just handed to us in this problem, everybody? Is everything just given to us? Do they say, here's distance 1, here's distance 2, here's distance 3, here's distance 4, add them up, go ahead. Yeah? Okay, let's find out. Let's find out. Again, I want to make sure that, we're all on the same page here. Let's find out, right? Let's find out. So here we go. Part 1, starting from home, Brian drove 40 miles in 1 hour. Okay, so let me go ahead and just mark that here. So part 2, writing that info down. So in purple, he drove 40 miles in 1 hour. All right, everybody. Which one of those is our distance? Which one of those is our distance? Right, the 40 miles for sure. The 40 miles for sure, that's our distance. So that's one of them that we're going to need. That's one of them we're going to need for sure. Okay, up next. After taking a 30-minute break, he then drove 3 hours at an average speed of 50 miles per hour. So for those of you that have been here before, there have been times where we need to account for that 30-minute break. But in this problem specifically, does that 30-minute break matter? In this case, it doesn't matter because everybody, if you're taking a break, what's the distance going to be for that time period? If you're taking a break, what's the distance going to be? Nada, zero, zip, nothing, nothing's happening. Remember, everybody, the question, because this is why, Parmita, this is why. If you start with the question first, you'll understand that you're looking for the total distance. And to get total distance, you only care about trying to find the distances at each point. Now, let's flip the script, though. Let's flip the script, Parmita. If this question was asking for the average rate for the whole trip, would that 30-minute break matter? Everybody, let me ask you that. If we're asking for the average rate for the whole trip, would that 30-minute break matter? It would absolutely matter because it's 30 minutes of doing nothing, and that would count toward the trip. But here, we're looking for the total distance. A break is literally just a pit stop. A break, it doesn't count toward the actual travel distance. It counts toward the travel time and the average rate for the whole trip, but it doesn't change the actual distance for the whole trip. So Parmita, let me know if that makes sense there. That was a genuine response. Let me know if that makes sense. Cool. All right, so let's look at the next part here then. So again, this doesn't matter. Doesn't matter. So over here, drove for 3 hours at an average speed of 50 miles per hour. So if I write that down, so this is part one, part two. So here we see 3 hours at 50 miles per hour. All right, everybody. I asked earlier, I asked if all of the distances were just handed out to us. Which one of these are the distance? The 3 hours or the 50 miles per hour? Which one of these is the distance? Ooh, y'all saying 50. Uh-oh. Y'all saying 50. Uh-oh. 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 Everybody, let's go ahead and tackle this together here. So I'm so happy we're doing these problems now and not later, right? So watch. Ooh, Zoom user got 150. Where did that 150 come from? Does anybody want to raise their hand and tell us why 3 or 50, neither of those are the distance, and how we can actually get the distance? Parmita, there we go. Let's go ahead and see if we can get your thunder stolen again, but go ahead.
Finally, I did it on time. Woo! Okay, so 50 times 3.
But why?
Because it's 3 hours, like 50 miles per hour, and it already gave you that hour, which is 3 hours. So 50 times 3, that's 150. Wait, not 3. Yeah, 50
okay,
times.
so the 3, you're saying that the 3 is time, so I can get that, right? 3 hours is time, but some people here are thinking that 50 is distance. But why is 50 not actually distance?
Because it says at an average speed. Like it doesn't really tell you the actual distance of it.
That's one thing right there. It says speed.
Yeah, that's how I think. It's like I was like, oh, it doesn't say distance or.
But how do we know? How can we prove just in this right here? How can we prove that that's not a distance?
Per.
Right there. Per. Right there. So everybody, do you see that? Thank you, Parmita. So everybody, do you see that there? The word per gives away that we are not dealing with distances. Is actually a rate. Miles per hour. Those are two different units together. That's always gonna be rate. Always, 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 always. That is a rate. 3 hours at 50 miles an hour. We can use that to find the distance for that part of the trip. Absolutely. Absolutely. But 50 is not the distance. Let's go and figure out what the actual distance is. Everybody, D equals RT. I'm going to plug in. I'm going to plug in. So here, D equals 50 times 3. Everybody, 50 times 3. Help me out, man. Hit me with it. 150 miles for that part of the trip right there. So far, we've got ourselves 40 miles over here, 150 miles right there. Are we done? No, because we see here that our buddy Brian takes another 15-minute break and then drove 60 miles per hour for 2 hours. Ooh, let's go ahead and write that down. So 60 miles per hour for 2 hours. Everyone, I'm going to ask you again. Is 60 a distance? Is 60 the distance? Pretty confident. That sounds good. Yeah, it's not. It is not the distance. It's actually gonna be the rate. Gonna be the rate. It's gonna be the rate. And what gives it away is the word per. Again, miles per hour. That's speed. That's how quickly you're driving. And so if you have 60 miles per hour for 2 hours, let's find that distance, because we can say distance equals rate times time. So everybody, what's that math gonna come out to? 60 times 2 equals what? 120 miles. 120 miles right there. So excuse me for a quick moment. Let me go ahead and just move this over here and try to bring this down just a little bit. There we go. So now that we have everything, and I know that was agonizing. I know that may have been agonizing. But do you see how important it is to be able to actually sort through the information that's given to you? Because we have a 30-minute break up there. We've got a 15-minute break up there. Useless for this problem because of the goal that's given to us. But if I changed one part of this problem, then those breaks would matter. If I changed it to what was the average speed for the whole trip, then it would matter. If I said, what was the total time for the trip, then that would matter. And then those rates wouldn't matter. The distances wouldn't matter. So I really hope that y'all are starting to see that all of the information that's there is not always what's going to be used, number one. And number two, it's up to you to figure that out. It's up to you. So that's what this training is all about. Yeah, some of the problems might feel boring. I know. I've been there before. I've been a student before. But the thing is, we have to make sure we know how to sort through the information and tell that story. So with that said, let's go ahead and add everything up because we're good now. We have all of the distances that we need. Now we can just find the answer down. So the total distance is going to be 40 miles per hour, or 40 miles plus 150 miles plus 120 miles. That's going to give us the answer. And if we just go ahead and add everything up right over here, that will give us zeros all the way down. That's going to be a 0. Then we have 4 plus 5, which is 9, plus 2, which is 11. And then we have 1, 2, and 3. And that's going to give us 310 what? 310 what? 310 mics, 310 moils. Abraham Moyles. That was pretty cool. Moyles, miles, mics. I think Christian Miles. Yeah, 310 total miles. 310. It's all good, guys. I love seeing it. So 310 total miles right there. Right there. My big old head in the way. 310 miles. And that's why it's D is the answer. So who here has had a big change in how they viewed this problem from before I went over it to after I went over it? And I want to know what that change was. Did it get more complicated for you as I went along with it? Or at the end of it, is it simpler now? Like, how do you feel about the problem now versus before we started looking at it? Way simpler, easier. You need another one. Absolutely. We got plenty coming up. We've got plenty coming up for sure. But I really just hope that you see the use. And again, starting with the question, understanding what it is that the goal is, and then going to the information. Because if you start with the information, a lot of y'all are going to be freaking out about that 30-minute break, about that 15-minute break. A lot of y'all will be like, if you read the whole question and then if you read the whole problem and then the question, a lot of y'all would have been like, yo, I know I got to use that 30 and 15 somewhere. I know I got to use it. Maybe I should just like add them in or divide them. Who's been there before? where you see information that's probably unnecessary and you're like, I don't know, but it's there. I got to do something with it, right? And this is what I'm training you to avoid, those common mistakes. Like Kesha, again, being here, we're working on it. We're working on it. All right. So I want to go ahead and go back real quick. Krishan, I got you. Krishan, you want to take a picture instead? Take a screenshot here. So Krishan, go ahead. I didn't forget about your boss. I got you. Go ahead and take a screenshot. Here we go. 5, 4, 3, 2. Beautiful. All right. So let's go ahead and go to the next one here. So this next one that we're going to be looking at now, we're going to be, again, just still having fun. Just keep it light, guys. I love you guys. So first things first, remember to read the question, mark down what you want to find. Then we're going to go into the passage and we're going to mark down the information that we have. Here's the game that we're going to play now, everybody. I'm going to give you a chance to do those first 2 steps. I'm not going to have you solve the whole thing. Don't worry about that. What I want to practice right now with you is this. Can you quickly identify the question? And then 2, can you quickly write down the information? And not just write down the information, but tell yourself what it means. So for example, instead of just writing, 22 feet per second. No, write 22 feet per second, parentheses, that's a rate, close parentheses. Identify what you're looking at, all right? So those are the only 2 things I expect. I'm going to give you 1 minute and 15 seconds to do so. So just those first 2 things, okay? It shouldn't take us a crazy amount of time to do that. I think it's fair if I say 1 minute, 15 seconds for that. So let me go ahead and get the timer up. All right, so here's the problem, and here's the timer starting. All right, cool. So there it is. Again, just write down what it is that you're looking for, and then write down the information and mark it. Question. I think it's pretty clear. The question literally says, what is Clinton's monthly average? So what is Clinton's monthly average? Everybody, what does that mean? What does that mean? If we're looking for monthly average, we're looking for the monthly what? Yeah, the monthly rate. Exactly. We're looking for the monthly rate. And there's a couple of different ways that we can really tell that that's true. So what I'm going to ask everybody to do is just put your pencils down, because I'm going to show something that's really obvious, that's really easy to miss if you're writing while I'm talking. So again, what's going on here is we are trying to find Clinton's monthly rate. Now you may be asking, okay, how do you know that this is a rate? How do you know? Well, everybody, these are the answer choices. The answer choices represent the question. And everybody, what gives it away in these answer choices? A, the word per, not A, but the word per. The word per gives it away. The word per gives it away. These are rates. Everybody, yes or no? Does that make sense? These are all rates. And so our answer must be a rate. Our answer must be a rate. It's all good, Parmita. So the answer must be a rate. It has to be. It has to be. It has to be. It has to be. And so boom, we're looking for the rate. And now pay very close attention here. What kind of a rate we're looking for? We're looking for the what rate? The what rate? Monthly. What does the problem give you? The problem gives you not months, but years. So this is where, again, with practice, you'll be able to point these things out instantly. You'll be able to see that you read minutes and then it says hours. You read months and it says years. You'll tell that difference automatically with practice, but you have to go through that practice. So here we go. So now let's write down the information. Step 2. So Clinton is a distance runner and has run 9,000 miles over the course of 2.5 years. So it's actually a pretty reasonable number though. 9,000 miles over 2.5 years, pretty reasonable. That's literally about 10 miles a day, I think. But with that said, let's go ahead and let's talk about this here. So 9,000 miles over 2.5 years. Okay, so we already pointed this out. We said that the problem is, we are looking for the monthly average, but we're given years. Everybody, what must we do before we proceed? Convert. We got to convert. That's right. We have to convert from years to months. So let's go ahead and get that done here. So let's convert 2.5 years to months. And so let's just go and work on this together, everybody. Let's just work on this together. Everybody, 1 year. So everybody, 1 year is how many months? Please, everybody get this right. Please, everybody get this right. 12 months. That's right. 12 months, 12 months, 12 months, 12 months. So everybody, is it safe to say that another year would be another 12 months? And then if we try to go for that next one, well, we can't really do that because we're looking for 2.5. So everyone, if 1 year is 12 months, what's half of a year? What's half of that going to be? 6 months. I hope we can agree on that, right? 12 months, 1 year, 12 months, 1 year, half a year. Oh, half of 12, 6. And so that'd be 6 months. And so everybody, what's 2.5 months or 2.5 years in months? +12 + 6, that's going to give you 30 months. That's going to give you 30 months. So now we have what we need. Now we can go ahead and plug in everything into our distance equals rate times time formula. And now we're good to go. Now we're good. Everybody, what should we replace d or distance with? What should we replace d or distance with? Yeah, that's right, Parmita. You're good. So it's going to be 9,000 is what we're plugging in. Because the distance, what we're trying to accomplish, or what we did accomplish in this case with Clinton, was 9,000 miles. So let me go ahead and remove the timer here. 1 second, guys. I'll get that timer out of the way. Kaboosh. All right, cool. So back over here, we have 9,000 for the distance, 9,000 miles. And then next, what are we plugging in for rate? What are we plugging in for rate? Yeah, just R, Mohammed. Just R, exactly. You're not plugging anything because that's what we're trying to find. We don't know what it is. We don't know what it is. I'm glad that you guys are sticking up for yourselves there when I pop quiz y'all. And then time, what are we plugging in for time? 2.5, right? 30, that's right. We're plugging in 30 for the 30 months that we found. Exactly. Plugging in 30 for the 30 months, that is the time. So this is the same thing as saying distance, so 9,000 equals 30 times R. Now, everybody, how do we solve this? How do we solve equations? We have to do that thing called working backwards from order operations, so work backwards. All right, so we see that's 30 times R. So what's the opposite of multiplying, everybody? That's going to be what? Dividing, right? It's going to be dividing. And so we're dividing by what on both sides? Dividing by what on both sides? Dividing by 30 on both sides. Sounds good. So with that, booyah, let's get it done. And we're good to go. Seriously, right there, the 30 cancels out. And all you have to take care of is 9,000 divided by 3. You can do that with long division or with some little tricks here. You can see that we have a 0 that cancels out with that 0. Then we have 900 divided by 3. Everyone, 900 divided by 3 is what? 300. 300 what? 300 what? Come on, give me it. 300 miles per hour? Miles per month. Miles per month. Yeah. Miles per month. There's your answer. There's your rate right there. 300 miles per month. And again, that's pretty reasonable. I mean, you got to take pretty good care of yourself in terms of, running, especially running that long, that often. Definitely going to develop some shin splints if you're not careful. But if you got the right shoes for it and the right technique, there are people out there that can run 10 miles a day easy, 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 easy. So there's that. So where did I find 30? So the 30 came from, remember when we converted the 2.5 years to months? We said 2.5 years, 1 year is 12 months, 12 months, and half a year is 6. 12 plus 12 plus 6, that is going to be 30. That is 30 months. So again, the 30 came from the conversion from 2.5 years to months. That's 30 months. So boom, the answer here is going to be 300 miles per month. Obviously, there's all that right there. Yeah, I'm a supermodel. Cool. But yeah, so there it is. It's going to be 300 miles per month. And I'm going to get myself out the way in a second here. But there is your answer. I'm going to make myself a little smaller so y'all can definitely take a screenshot here. I got y'all. All right, take a quick screenshot. Do your thing. If you need it, go ahead, go ahead, go ahead. And also, if you're already done writing this down or taking a picture, let me know how you're feeling. How are we feeling about this one? Was this easier or harder than the last one? Was this one easier or harder than the last one? A little more complicated? Hey, that's fair. That's absolutely fair. Once you get, what was that? Once you get the process down, it gets easier. Absolutely, Mario. Absolutely. David, this one was a little harder. Converting a mixed number, right? 2.5, that can definitely trip us up a little bit. But did it help that we were thinking about it intuitively? Like, okay, 1 year is 12 months, second year is 12 months, then half a year. And that's really how I want you to aim to think about it, man. Intuitively, not complicating it, just thinking about it naturally, for sure. You're catching on, Carrie Ann. Need more practice, a little hard. John G, no worries. Difficult, Abraham. And getting it a little harder. All right, cool. Sounds good, guys. So here's what we're going to get into next. All right. So remember the things here. Like these are going to be the keys all day. All right. So the keys here are bienvenidos a matemáticas. We are looking at being consistent. Okay. Not like me because I'm speaking Spanglish right now, but we get to be consistent here. Remember to represent the formula the same way. This is the number one killer, all jokes aside, this is the number one killer when it comes to the single object rate word problems. It's all about understanding how to represent your situation. Biggest thing. So remember that if you're looking for Bethany's time, you'll use Bethany's distance and Bethany's rate. Not Chad, not Anderson, not Chris, no. Now, if you're looking for the time for the entire trip, again, only focus on the entire trip. Not this one little piece here, there, it all counts. Okay, it all counts. So what we're going to do next is we are going to practice. I'm going to give you 3 minutes here. All right, 3 minutes. So basically what we're going to do is first, you're going to figure out what is it that you want. Then you're going to write down, well, what do I have? And I need you to write these things down. I need you to do this, not as quickly as possible, not frantically. Don't kill yourself here. Like, don't try to rush it. I'm not looking for that. I'm looking for you to be able to do what you can do as comfortable as you are right now. Okay. So if that means that you don't quite get to calculating, but you have the perfect setup and you exactly know what you're looking for, but you ran out of time calculating, that's okay. Totally okay. Totally okay. Because guess what? We can get faster at calculating. We can get faster at setting up. But if you're going so fast that you get frustrated and don't even try, that's where I have a problem, because you're not learning. You can at least learn by still taking your time and still being timed. So everybody, does that make sense? Work at your pace. Don't worry about the timer. The timer is just there so that we can all advance together. It's not an indication that you're a failure or good or not. It's just there so that way we can move on at a good pace. Does that make sense, everybody? Cool. Yeah. And if you like, I typically don't say this, But while we go through the class, if you want to use a calculator to basically give yourself the confidence that you know that your setup is correct, I'm all for it. I've allowed that before, because while you build your confidence that you're doing the right setup, sure, use a calculator. Use a calculator. That's fine. But when you practice more and more and more, hell no, don't use a calculator. All right. So for right now, please feel free to use one. Feel free to use one. But then later on, drop that calculator because you know what the deal is. So here we go. Let's get this timer up here. Let me stop talking now. All right, let me set you to 3 minutes. All right. And I'm giving you a little bit of extra time, just a slight bit of extra time, but that's okay. Go. So first things first, read the question. The question reads, what was the average speed? So what was, let me use just a red underline. What was the average speed for the trip there? So you see here, average speed. Everybody, let's just break it down here. Average speed denotes what? What are we looking at there? Average speed means what? Yeah, it's going to be rate. It's going to be rate. So average speed means rate. That means rate. And also when you look at the answer choices, they all include the word per. So we can also strengthen that assumption and say, yeah, for sure, that's definitely going to be a rate. Definitely looking at a rate. All right, cool. Now remember, everybody, context matters, right? What we're talking about matters. So whose average speed or whose rate are we looking for? What average rate? Like, what are we looking for? The cargo ship? Okay. Can we be more specific? Do we need to be more specific? Do we need to be more specific? For which trip? The whole trip? The trip there? The trip back? Like, see, this is where we need to pay attention, right? I got y'all. So sweet. So right here, it says what was the average speed for the trip there? Okay, the average speed for the trip there. So we're looking for the rate for the trip there. Yes or no, everybody? Does that make sense so far? Step one, when reading the question, we see that we're looking for the average speed for the trip there. So I'm telling you right now, like understanding the context, the story, what we're actually talking about, biggest step, man. It's not ever going to be the calculation. It's just going to be understanding what the numbers mean and how they fit in. That's really what this is about. So step two now, let's dive on in. Step two, let's really look at the information we have, because the problem was pretty specific, right? We're looking for the rate for the trip there. Well, that's oddly specific. You know, they could have just said for the trip, but then, it's actually not that simple. If you just gloss over the problem, you see that it says a cargo ship went to a nearby island and back on the same route. So it went to the nearby island and then it went back on the same route. So I'm gonna tell you right now, we're gonna have to mark two different sets of numbers, but let's watch this right here. Everybody just confirm for me, same route. What assumption can we make if you take the same route there and back, or if two people take the same route? What can we assume about anything? Kelsey says same distance. Antoine Jaguar, same distance. Abraham, Evan, Parmita, same distance. Exactly. So I'm going to mark this here. There and back have the same distance. Equals same distance. Okay, it's the same distance. I got to make sure we understand that before we move forward. So one quick check, yes or no. Are we all good on that? The same route means that the trip there and the trip back are the same distance. It's going to be very important in a couple of moments. Very important in a couple of moments. But I want everybody to let me know, yes or no. Does that make sense? That's way, way, way too important. All right, cool. Sounds good. So let's go ahead and take a look at the information now. So it says the trip there took 5 hours. So there, 5 hours. So I'm going to write that over here. 5 hours. Everybody, hours is what kind of unit? Yeah, it's gonna be time. Gonna be time. And then over here it says the return trip took 6 hours. So the return trip took 6 hours. Return trip right here, 6 hours. All right, cool. Now, here's the thing, everybody. Remember that our formula is literally D equals R times T. Distance equals rate times time. I have time right here. I'm looking for the rate. Wouldn't it be great if I just had the distance? If I had the distance, wouldn't this be an easy problem? Right, it's all good, Jose. Yeah, I get it. I know this is where some of us got lost for sure. But if we had the distance, like if we had a solid number for the distance, that's game over, right? Because if we have the time and we have the distance, we could find the rate. We could just go ahead, set up the formula, divide, we're good. But the fact of the matter is the problem doesn't just like specifically say it, right? Like, how are we supposed to get there? How do we get it? What are we supposed to do? I got you. So move forward here. Make sure to take down all of your information. The ship averaged 25 miles per hour on the return trip. Okay, right here. Average 25 miles per hour on the return trip. So over here, 25 miles per hour. So this is time. This is rate. Everybody, what did we say is the same as the distance there? What's the same as the distance there? What did we say? The distance there is the same thing as the distance back. One more time. The distance there and back, they're the same distance. Remember earlier how we said, hey, they're going on the same route? They're going on the same route. That's exactly what we're talking about right here. Because guess what we can do? What we can do here, what we have the power to do is we have the power of finding the distance right here. We can find this distance right there. If we can find the distance for the trip back, yes or no, everybody, doesn't that mean that we know the distance for the trip there? Doesn't that mean that we have it? And that's what we're going to leverage. That's what we're going to take advantage of. And so let's take care of it right here. 25 multiplied by 6, let's get it done. 25 times 6, that's going to give us 30. 2 multiplied by 6, that's going to be 12. Add the 3 is 150. So everybody, the distance is 150 what? 150 what? Miles. It's 150 miles, exactly. And so 150 miles, and everybody, guess what? We can copy and paste that right there. Because remember what we said? What did we just say? The distances are the same. And so guess what? All we have to do now is go ahead now and fill in our formula. And we're actually pretty good here. So I believe that was Evan earlier who was really agreeing with me that it's, it wasn't really all that obvious. But Evan, I got to ask you now, boss, because I was paying attention to the chat there. Evan, are we feeling a little better now about how we were able to get that distance? Let me know, man. Are we feeling a little better about how we were able to get that distance? And then Jose, I'll take your question before we actually solve this. Go ahead, man.
Like, that's where I got lost because I did exactly what you did, 25 times 6. And then I was like, what do I do with the 150? But then I see you.
Pause. Jose, what was the goal of the question again?
The rate. Like, I knew you had to find the rate. I knew you had to divide, but I was like, but then, like, this is where I got, like, thrown off. And, like, I was like, what do I do? Everything started going through my mind. But I was like, what do I do with the 150? What do I divide it? I thought, but now I see.
But it's okay, though, right? Because we have to stick to what the problem is about. And the problem is about finding rate. And if you want to find the rate for the trip there, you need to find the distance for the trip there, and you need to find the time for the trip there. Starting to see where those notes are coming in from earlier?
Now I see where it threw me out because I knew I had to find the rate. I knew once I saw like the answers, I was like, oh, I have to divide. But then I was like, what do I have to divide? I was like, I did that, but now I see now.
Okay, I'm good, man. This is growth. This is growth happening. So now that we have the 150 for the distance, we need to find the rate. Keep in mind exactly what we're doing from the very beginning. And so if we just go ahead and bring this over, distance equals rate times time. The distance is 150 miles. The rate is what we're looking for. And we have 5 hours. And we have 5 hours. And so what we're going to do now, everybody, is divide both sides by that 5. And that's going to give us the rate. And so if you have a question, make sure to raise your hand. I'm going to go ahead and call on everybody in a second. But here we divide by 5. And everybody, we get the rate equals 150 divided by 5. What's that going to be? What's that going to be? 30. 30 what? 30 what? Miles per hour. Exactly. And that's the answer. The rate for the trip there, is 30 miles an hour. It's going to be D. Now, I saw a question earlier asking, well, how do you know that the 6 and the 25 go together? Very valid question, right? Very valid question. The reason that the 6 and the 25 go together is because over here, the ship, read with me, the ship averaged 25 miles per hour on the return trip. And then over here, return trip took 6 hours. So you have 6 hours for the time for the return trip. Then you have 25 miles an hour for the rate for the return trip. And so you use the rate for the return trip, the time for the return trip to get the distance for the return trip. Oh, but wait, remember we said the distance there and the distance returning is the same. So that 150 that we got right over here, that 150 right here, we can grab that, boom, and we can use it for the distance there as well. So Keon, though, so I see where your mistake came from, and I love that you were able to identify why that mistake was made. Now we're able to see with this explanation where those numbers should have gone. Are you able to see that now? Because I'm gonna start taking questions now. ABK, the video for this class is gonna be up first thing tomorrow morning. Sure I understand. Jesus. This class is gonna be up first thing tomorrow morning, 9 o'clock in the morning. So go ahead, Mohammed. Oh, Parmita took her hand down, but go ahead, Mohammed.
So I got confused at the beginning. Hello?
I can hear you.
Yeah. So what we have two distance, right? I mean, going and come back.
Right.
But we have the time for the first one, but we don't have the rate.
Right.
And we need actually we don't have the distance. We need to find the rate.
Right.
Okay. So since it's same route, we use the distance from the second trip.
From the trip back,
is
yeah.
So we already have the rate and the time. Right?
Right here. So in blue, we have the rate and the time for the return trip, which helps us get the distance. Because remember, distance equals rate times time. So that's how we got the distance here.
Okay.
And then once we got this distance, what can we do with that?
So you use the first trip as a distance to find the rate.
Exactly. And so once you have that 150 right here, you can plug that in for the same distance.
And since we drove 6 hours for 25 miles, and we have to make it up at the second trip, the first one, so that's mean that we have to the distance have to be more.
No, the distance is the same right here.
I'm sorry. The rate. Sorry, I take it back.
Oh yeah. Because you did it in less time for the same distance, the rate would have to be more. So you can automatically eliminate A and B, understanding that for sure. And then if you ran out of time, you could take a guess between C and D for sure.
Okay, thank you.
Yep, I got you, man. What's up, Sia or Asia? Even though you don't want me to call you that, go ahead and go Sia. What's up?
So you knew that we were looking for the rate in this because of it said the average speed and the question said per mile. That's how you knew.
Yep, exactly. Average speed. Remember that speed and rate are the same thing for all intents and purposes here. Yeah, speed and rate are the exact same thing for the ASVAB.
Okay, I was just confirming that because I thought I heard that a few times and it didn't click in my head. Thank you.
Hey, you're good. You're good. Again, the more the more you air it out, the better it is. Yeah, you're good. And then coming up next, go ahead, Savian.
Where did you get the 5 from in the R times 5?
Right here.
Okay.
Yeah.
Oh,
So
okay.
for the rate, we had the 5 hours. We had the 150 for the distance. So I plugged everything in: distance, rate, time. 5 hours is the time, and then we did our thing by dividing both sides.
Okay, thank you.
Hey, no worries. I got you. All right, what's going on, Evan Ochoa? What's going on, boss?
So my question is, when you're at the final step after you multiply 25 miles per hour with 6 hours, you don't use the 25 anymore for D equals R. You don't use the 25 in your R solution, correct?
Nope, because all we needed was the distance for the trip there, and we found the distance for the trip back. And because it's the same route, they're the same. So that 25 and that 6 at this point, now that you have the distance, doesn't matter anymore.
Okay, that makes sense now. Thank you.
Yeah, no worries. I got you. All right, so with that, those are some great questions, everybody. I'm glad I could clarify. So on a scale of 1 to 10, how's everybody feeling about this problem? Because again, this is a problem that could absolutely appear. How are we feeling on a scale of 1 to 10, with a 1 being, yo, I can't believe I came to this class today. I should have just taken my break until the new year. With 10 being, okay, this makes a lot of sense. This definitely calmed me down a little bit. Feeling all right about this. Hey, Dorian, I love seeing that. You're getting better at setting things up. That is what's up, man. That's what's up. So with that there, what we're going to do is we're going to get into the next practice problem. Remember, guys, it's all about the setup. Really, again, don't worry about, trying to get rushing at the final answer. If you can create a proper setup, you're good. You're good. That's really what I'm looking for. All right. And I think someone was asking about me doing the same class tomorrow night. No, what I'm doing is we're doing a follow-up to this one, where today we're only doing a single object. So I hope you saw that it's one cargo ship going there and back, or it's one person doing a whole trip. It's one thing or one object doing the distance, rate, and time. Tomorrow, we're going to be looking at 2 objects. So these are problems about, one plane is trying to catch up to another. You're filling up a pool, but there's also a leak. We got 2 cars driving away from each other. This one at this speed, this one at this speed. Anybody ever heard those problems before? Those catch-up problems, those cars driving away from each other, filling up a pool that has a leak in it. Yeah, that's what we're doing tomorrow. Today, we're focusing on the single object. Tomorrow, we're focusing on the dual or triple or more objects. So tomorrow is a follow-up for sure. Exactly, where you add or subtract the rates themselves or the distances or the times. Yeah, those suck. Exactly. And that's why you should be in the ASVAB All Access program. I'm kidding. I'm going to talk about that more at the end of class. Let's go ahead and keep focusing up here. I got y'all. So another 3 minutes. 3, 2, and 1. Let's kick some butt. Go. Let's go ahead and check this out here. So this is one of those problems that, and David, let me go ahead and make sure that, I want to see your face the entire time, boss. Okay. Did you think that, David, did you say this one was hard? Let me see. David, do you have an answer? You said it was hard. No worries. I just want to see your face, man. We'll do this. It's all good. So let's go ahead. Dave, you don't love me, man. So here we go. The question asks again, how long does it take to bike to school? So here's the thing, everybody. That's what we're looking for. How long does it take, which means time, and then to bike to school. So time to get to school. Everybody, yes or no, is that correct? Like, is that what we're looking for? We're looking for the time it takes to get to school. I see some people are having some revelations with Jesus in the chat box. Okay, sounds good. So let's go ahead here and let's see what the fuss is all about. So we're looking for the time it takes to get to school. Let's go ahead and write down the information that we have and let's see what we can do. So here, on the way to school, Bianca bikes uphill. That sucks. And on the same route back home, she can bike twice as fast going downhill. Okay, cool. So think about it. Just imagine the story. But remember, it's all about storytelling. It's all about storytelling, everybody. So look, on the way to school, Bianca's biking uphill. So she's like, man, this sucks. This sucks. But then on the way back home on the same route, she's going downhill. So she goes twice as fast downhill. So coming back home, she's going twice as fast. Okay, cool. So if it takes Bianca 40 minutes to get back home from school, how long does it take to get to school? Everybody, this is a very sincere problem. Very, very, very sincere problem. And by sincere, I mean very straightforward. Everybody, it's in the pudding. The proof is in the pudding right here. It says she can bike twice as fast going downhill, and it takes her 40 minutes to get back home. So everybody, let's ask ourselves, and I'm going to draw a little demonstration here. Let's say here is school, and here is home. Yes, I can draw, and I will print this out for my parents to see. So on the way there, or excuse me, on the way back, twice as fast as going just from home up. So everyone, if it takes 40 minutes to get to school, what should we do with the 40? Should we multiply it by 2 or divide it by 2 to find out how long it takes to get to school? Just really think about it. Should we multiply by 2 or divide by 2? And for those of us that are saying multiply, is it fair to say that we're saying multiply because if you are going twice as fast on the way home, doesn't that mean that it would take you twice as long to go to school? And if you look at the diagram, this supports it. It's going to take twice as long to get up a hill than go down the hill. And so naturally speaking, that should definitely make sense. That should definitely make sense here. It's going to take you twice as long to get up than to come back down. And so what we're going to do is multiply by 2, because that's going to give you 80 minutes. And that's going to be going back home. That's going to be going back home. And so with that said, everybody, right there, everybody question, how many minutes are in an hour? Okay, 60 minutes. So let me just do some real quick. So can we change that to 60 minutes and 20 minutes? Because 80 is 60 plus 20. So is it fair to say that we have 1 hour plus 20 minutes? Or B, 1 hour, 20 minutes? And there it is. And there it is. So David, please say your piece. Go ahead.
Okay, I don't know if you can hear me. Can you hear me?
Yes, sir. Go ahead.
Okay, yeah, it's funny that you say that because as soon as you said something and you mentioned my name, I did the whole mental math in my head. I was like, wait a minute. Okay, so 40 times 2, that's 60. But if you minus 2, that's going to be, wait a minute. I did the whole mental math thing in my head. I was like, oh my gosh, I actually got the answer just by looking at the question.
Hey, it's all good, man. It's all good. It is all good.
It was that simple. That's crazy.
And that's the thing, that's with practice, we'll learn not to overcomplicate things. We'll learn.
Exactly. And the surprising thing about myself, I did that all in my head. I ain't write it down.
Nice. Right on. And you can do this one in your head for sure. And I
Mental
want to ask you
math.
about it. Like, and David, you specifically, man, have you ever done a problem where, like, for example, we all know that if I ask you what's 1 + 1, I'm asking you to add 1 + 1. If I say, what's the sum of 1 and 1, that still means add 1 and 1, 1 + 1, 2. Now, if I phrase it like this, if I say, all right, Dimitri has 1 watermelon and, Mr. Vegas has another watermelon, in all, how many watermelons do they have? Now, it's saying the same thing, but you see that the level of complexity to decipher that, to really cut through the noise and actually get to the actual math, you see that there's a lot more in the way, right? And so what I want to ask is, everybody, is this that type of problem? Is this that type of problem where you just have to cut through the noise to get to the simplicity of the operation? Like, is this that type of problem? That is literally something very simple, just masked with a bunch of words. That's all it is. And that's what a lot of the ASVAB problems are. And depending on how much practice you have, they're all like that. It's all about cutting through the noise. It's all about cutting through the story. So I really hope that I proved the point here in terms of why these problems feel complicated, but again, what we can do to make them feel less complicated. Now, we definitely have time for one more problem, so we will do that for sure. I got you. So Alvin, the way that I got 60 minutes is because you knew that if I just had 80 minutes as the answer, notice how 80 minutes isn't there. 80 minutes is not here. And so I knew that perhaps I would have to convert. I mean, you didn't even have to convert. You would have known it's 120 because it's the only one that's an hour, a little more than an hour. But long story short, we see that 60 minutes is 1 hour. And then you have the leftover 20 minutes. 60 + 20, that's 80. That's 80 right there. So we had 1 hour and the leftover 20 minutes right there. Right there. Again, this is definitely one of those problems that we may not have had to overcomplicate. So Mohammed, I'll go and give you a shot there with the mic, and then we will move forward here with the last problem.
So is this about variable? Like I was saying, since the distance is same thing, because what I did D1 equal D2, then I put right 1 T1 equal right 2 T2, then I put the numbers later on. Do you understand what I mean?
Yeah, I know exactly what you're saying. And you're saying everything correctly here, because like, yes, the distances are the same, the rates are the same. But what we overcomplicated here was
at the time we double up.
Hold on. We were never given a distance.
Mm-hmm.
We were never given a rate for either way. We were only given the relationship between the rates. So whenever you find yourself in arithmetic reasoning on the ASVAB with not being given solid numbers, but only given relationships with a bunch of numbers, that's when you know it's probably a lot easier than you think.
Okay.
And that was the 40, just times 2, get 80 minutes, convert that to 120, and bam.
Okay. Thank you.
Gotcha. Parmita, go ahead, and then we are going to this next question here.
Can you hear me, Coach?
Yeah.
Okay, so I know this is off topic, but do you have like extra worksheets that I could print out to practice more of this?
If it's not on the math bootcamp already, I can make some for you.
Yes, please.
That'd be
awesome. Okay, thank you.
Hey, no problem. And then Diallo, that was a quick one. So go ahead, Diallo. Your mic's on, but I don't hear you. No worries. Go ahead and type it out, Diallo. I got you because I want to make sure we get to this last one here. But yeah, I can't. There's nothing coming out of your mic. But go ahead, type it out. I got you. So here we go, man. 3, 2, 1. Let's get into this last one here. And also, if you are looking forward to doing more classes with us, just look forward to the end of class where I will show you how to sign up for the program. But for right now, let's go ahead and kick some more butt. Let's get this last one in. Let's get to it. So how long is today's bike ride? Sounds good. So what we're looking for is how long. So basically the time. And then today's bike ride. So today's ride. So time for today's ride. So let's go ahead here and let's just cut through straight to the calculating because I'm afraid I may not have enough time to also introduce the all access program to everybody, but I'll make sure to still hit the main points here. So what we should have noticed here is this right here. You decide to bike the same distance, meaning the distance yesterday and today is the same. So distance yesterday. Everybody agree or disagree? Distance yesterday is the same as distance today. Agree or disagree? Cool. Agree. Sounds good. Then it says, since we're looking for the time for today's ride, is there anywhere here that shows you the distance or the rate for today's ride? Is there anything that gives it away for us? Any of those clues? Any clues? Any clues? Any clues? The answer to that question should be yes, but kind of not really, because of this right here. It says 6 miles per hour slower than the day before. So does that mean that the rate is 6? Or does that mean that the rate is 18 minus 6? You got to subtract, right? You got to pay attention to those keywords here. 6 miles per hour slower, right there, slower or less than. Something we definitely got to pay attention to because the rate for today is going to be equal to the 18 miles per hour minus 6 because it's 6 miles per hour slower, which gives us 12 miles per hour. So again, that's the rate for today. So if that was your mistake, go and call it out. Yeah, if you made that mistake, go and call out where you made that mistake. So that's okay. Jag, it's all good. It's all good. And so then from there, we don't have the distance. But the thing is, hey, we know that the distance yesterday is the same as the distance today. And so what we can do is we can go ahead and find that distance for yesterday because it'll be the same as today. So how can we do that? Well, we see right here, 6 hours, 18 miles per hour for yesterday. So let me go ahead and take out some of this circling here because it's definitely going to look a little intimidating if I don't highlight it the right way. So it says yesterday, 6 hours, 18 miles per hour. So the distance for yesterday is going to be equal to 18 miles per hour. That's the rate times 6 hours. That's the time. Anybody know what 18 times 6 is off the top of their head? That's 10 times 6 plus 8 times 6. So that's going to be 60 plus 48 or 108. Mental math for the win. Oh, you guys got it faster. Okay, no worries. So 108, 108 miles right there. Distance equals 108. There's our distance for today. It's the same. So let's go ahead and plug that in. And so we have that. Again, same. Let me go ahead and take that away. I see it. Bam. So same as today. All right, cool. And so now we have that 108. So for today, we have 108 for the distance. We have 12 for the rate. What's that time? All right, cool. Divide both sides by 12, and we get time equals 9. 9 what? Oh, y'all quick with it already. 9 hours. That's right. 9 hours. And bam, we're good. So who here got it right from the very get-go? Who here saw that? Okay, 18 minus 6, cool. Distance from yesterday and today, cool. Like who was all good? And I want to know also who only made one mistake. Like, oh crap, the 6 was not the rate. It should have been 18 minus 6. Or I forgot that the distances were the same. You know, who made just one mistake? You forgot the 108? Okay, so you forgot what it was used for? No worries, because you saw that these problems were getting like slightly more complicated. So the fact that you're keeping up, if you're looking at this for the first time in a while, or you were confused when you came in, if you're able to understand this, you should have a lot of hope for the ASVAB, because whether this is your first, second, or third, or fourth class with me, this shows that you have the ability to learn. And remember, at the end of the day, it's all about growth. You know, we can't expect to start perfect. That's not realistic at all. You know, perfection's more so a path, not a place. And I really want everybody to realize that, because once you realize that perfection's a path, not a place, it's a lot easier to jump on board and try and learn, as opposed to looking at it and thinking that it's impossible.